You are about to find out what happens behind the closed doors of one of the most secretive and profitable industries operating right now on American soil. What if the old cell phone sitting in your drawer, the one with the cracked screen, the dead battery, the model you replaced 2 years ago and completely forgot about, was actually worth more than you ever imagined? Not to you, not anymore, but to a network of hidden facilities, industrial machines, and billion-dollar operations that most people will never hear about. That forgotten device is pure gold, literally. And the process that transforms it from useless trash into raw material for some of the most advanced manufacturing chains in the world is something the industry has spent decades keeping far from public view. What you are about to see is not what they want you to know. This is the forbidden revelation of how old cell phones make billions in the United States, and the industrial machine behind it is more powerful, more secretive, and more shocking than anything you could have imagined. Every single year, Americans retire more than 150 million cell phones. 150 million devices, each one carrying inside its compact frame a hidden universe of rare materials, precious metals, and engineered components that took the most advanced factories on the planet to produce. Gold, silver, palladium, copper, cobalt, lithium, indium, tantalum. Elements so rare and so valuable that mining them fresh from the earth costs fortunes and destroys landscapes. Yet most of these phones end up in a drawer, or worse, in a landfill. And that is exactly where the billion-dollar secret begins, because somewhere between the drawer and the landfill, a network of industrial operations moves in complete silence, collecting, sorting, shredding, and extracting every particle of value from those discarded devices. The process is hidden from public view. The facilities are unmarked, the profits are staggering, and tonight you are getting inside. The scale of this industry in the United States alone is almost impossible to comprehend without seeing the numbers. The American e-waste recycling sector generates over $3 billion annually, and that figure represents only the documented, visible portion of the operation. The real machinery, the private smelters, the licensed dismantling facilities, the chemical extraction labs buried inside industrial parks in states like Texas, Ohio, Nevada, and California. These operations run 24 hours a day, 7 days a week, and the materials they recover feed directly into the supply chains of some of the largest electronics manufacturers in the world. Your old phone is not garbage, it is feedstock. And the factories waiting for it operate with the precision of a surgical unit and the hunger of a machine that never sleeps. Before we go any further into this forbidden process, there is something you need to do right now. If you have ever wondered what really happens inside these secret facilities, if you have ever asked yourself why these operations are kept so far from public knowledge, type the word gold in the comments right now. Let the algorithm know that you are paying attention, that you are one of the people who actually wants to understand what goes on behind the walls of industries that prefer to work in the dark. Hit the like button, because this is the kind of content that takes serious research to uncover. And your support is what makes it possible to keep pulling back the curtain. Subscribe to this channel and activate the notification bell so you never miss another revelation. The next videos are going to go even deeper into processes even more hidden than this one. Now let us get inside the facility. It starts with collection, and the collection network is the first secret that the industry protects. When you drop your old phone into a recycling bin at a carrier store, at a big box electronics retailer, or through one of the mail-in programs that have exploded in popularity over the last decade, that device enters a logistics chain that is invisible to you the moment the bin closes. These phones are consolidated at regional aggregation points, massive warehouse facilities that receive incoming shipments from hundreds of collection sites simultaneously. The sorting begins here, and it is far more sophisticated than anyone on the outside would guess. Devices are initially separated by condition, by brand, by model year, and by estimated material value. The ones still carrying resale potential are pulled from the stream immediately. Refurbishers, secondary market dealers, and export brokers are waiting. A phone that cannot be sold in the United States can often be sold in a secondary market abroad, and that transaction happens fast, efficiently, and profitably before the device ever reaches the next stage of the recycling process. Only the truly dead devices, the ones with no commercial afterlife, move forward into the industrial machine that turns them into raw material. Those devices reach what the industry calls a primary processing facility, and this is where the transformation begins. The first thing you notice, if you were somehow allowed inside, is the sheer scale of the operation. Conveyor belts stretch the length of football fields. Industrial shredders the size of small buildings dominate the central floor. The noise is constant, mechanical, overwhelming. Phones arrive in enormous containers, hundreds of thousands of units moving through intake stations, where the first mechanical separation begins. Batteries must be removed before shredding. This is not optional. It is a matter of physical safety. Lithium-ion batteries, when punctured or compressed without proper protocols, generate fires that are nearly impossible to extinguish with conventional methods. The extraction of batteries at this stage is done with a combination of automated machinery and trained human operators working inside controlled environments with fire suppression systems active overhead at all times. The batteries are diverted to their own processing stream, a separate and equally secretive part of the operation, where the lithium and cobalt inside them will eventually be recovered and sold back into battery manufacturing supply chains. The rest of the phone moves forward. What remains after battery removal still contains an astonishing concentration of value. The circuit boards, the cameras, the speakers, the antennas, the structural frames, all of it carries metals and materials that are worth recovering. The devices enter the primary shredder, and what comes out the other side looks like nothing recognizable. The shredded material, called e-scrap, or electronic scrap in the industry, is a fine, mixed fraction of plastics, metals, glass, and rare elements, all ground together into a heterogeneous mass. This material is visually unremarkable. It looks like industrial waste. It is anything but. From this point, the separation process begins, and this is where the technology inside these hidden facilities becomes genuinely extraordinary. The first separation stage uses physical methods. Powerful electromagnets pull ferrous metals, primarily steel, from structural components out of the mixed stream. Eddy current separators then target non-ferrous metals, aluminum and copper primarily, causing them to behave differently from the surrounding material under intense magnetic field variations and ejecting them from the stream with precision. What remains after these two stages is a complex mix of plastics and the precious metal-bearing fractions, primarily the powdered and fragmented circuit board material that carries the gold, silver, palladium, and other high-value elements the entire process is designed to recover. The plastics are separated next using density-based techniques, air classification systems that exploit the weight differences between material types to pull them apart. By the time the material exits this multi-stage physical separation system, the precious metal fraction has been concentrated dramatically. What started as a general mass of shredded electronics has been refined into a material stream that is now rich enough to justify the next and most secretive stage of the operation. That next stage is smelting and hydrometallurgical refining, and this is where the true value of the billion-dollar industry is unlocked. The concentrated e-scrap fraction is transported to specialized smelting facilities, some of the most tightly controlled industrial operations in the country. These facilities receive material not only from cell phones, but from the entire range of electronic waste streams, computers, televisions, industrial equipment, medical devices. The smelters run at temperatures exceeding 1,000 degrees Celsius. The organic components, the plastics and residual materials that made it through the physical separation stages, are burned off in controlled combustion processes that generate energy the facility uses to offset its own operational costs. What remains is a molten alloy of metals, a mixture of copper and precious metals called black copper or blister copper, depending on the specific process, which carries dissolved within it the gold, silver, palladium, and other elements that were present in the original devices. This molten alloy is cast into anodes, large slabs that will feed the next stage of refining. The anodes enter an electro-refining process. Immersed in an acidic electrolyte bath with a thin sheet of pure copper as the cathode on the opposite side of the cell, an electrical current is applied. The copper dissolves from the anode and deposits as ultra-pure copper on the cathode with extraordinary precision. The precious metals, being less reactive, do not dissolve. They fall to the bottom of the cell as a sludge. This sludge, called anode slime or precious metal slime, is collected periodically and processed further using hydrometallurgical techniques, a series of chemical leaching and precipitation steps that separate the gold from the silver, the palladium from the platinum, each element recovered in a form pure enough to be sold directly into manufacturing supply chains. The gold recovered from cell phone recycling is high-purity gold. The silver is high-purity silver. These materials re-enter the global metals market and are purchased by the same industries that originally put them into the phones. The cycle is closed. The profit is real, and the entire operation moves forward day after day in facilities that most people drive past without a second glance. One metric that the industry rarely publicizes illustrates just how extraordinary this process is. 1 metric ton of processed circuit boards from mobile phones contains more gold than 17 tons of gold ore mined from the earth. 17 tons of rock blasted from the ground at enormous environmental and financial cost, processed through its own crushing and chemical extraction operations, yields less gold than a single ton of the circuit board material recovered from your discarded devices. The economics of urban mining, as the industry calls this process, are not just viable. They are, in many cases, superior to primary mining from a pure return on investment perspective. The raw material arrives pre-concentrated by the engineering that went into building the original devices. The gold is already alloyed in thin layers on circuit traces. The copper is already drawn into fine wire. The labor of concentration has already been done at enormous cost by the original manufacturers. The recycler inherits the result of that work and extracts the value from it. The rare earth elements present in mobile phones add another layer of value and complexity to this operation. Elements like neodymium, used in the powerful miniaturized magnets inside speakers and vibration motors, and indium, used in the touch screens that define the modern smartphone interface, are materials that do not exist in significant concentrations anywhere in the United States. Their primary global supply comes from China, and the geopolitical sensitivity around rare earth supply chains has made their domestic recovery from e-waste a matter of national strategic interest, not just commercial opportunity. Recovery operations for these elements are at the frontier of the industry, still developing the technology to make extraction economically viable at scale, but advancing rapidly. The facilities pursuing this work operate under layers of corporate and sometimes governmental confidentiality. They represent the cutting edge of what the recycling industry is becoming. Not just a scrap operation, but a critical component of American industrial and national security infrastructure. The workforce inside these facilities is another secret the industry keeps carefully. The people who operate the shredders, who manage the chemical baths, who work in the smelting operations, who handle the material at every stage of this process, are skilled industrial workers operating in environments that require significant training, rigorous safety protocols, and constant exposure to materials and processes that demand respect. The personal protective equipment inside a precious metal refinery looks more like hazmat gear than work clothes. The chemical exposure risks are real. The fire risks in battery processing are real. The operational discipline inside these facilities is extraordinary, and the wages reflect the skill and the risk. These are not low-skill operations. They are sophisticated industrial processes staffed by professionals whose expertise is as rare as the materials they recover, and the numbers keep growing. As mobile devices become more sophisticated, as the materials engineering inside them becomes more complex, as the concentration of valuable elements per device continues to increase with each new product generation, the value locked inside the e-waste stream grows with it. The industry is expanding. New facilities are being built. New technology is being deployed. New materials are being added to the recovery list. The billion-dollar figure of today is a floor, not a ceiling, for what this industry will become over the next decade. Now tell me something. Before today, did you have any idea that your old phone was carrying this much value? Did you know that a global industrial machine, hidden behind unmarked warehouse doors and confidentiality agreements, was built specifically around recovering what you threw away? Drop your answer in the comments right now. What shocked you the most about this process? Was it the gold concentration, the smelting operation, the rare earth recovery? Tell me below, because the conversation in the comments is where this community really comes alive and your perspective matters. The next revelation is already waiting.